Alright, so today we'll be talking about series. Most of the rest of this chapter is going to be about series. And so today we want to talk about, well, what is a series? And then talk about a few things we can talk about them. Alright, so if we want to look at the idea of a series, the way I like to think about a series is that we have a sequence, some infinite sequence, and we add up all of the terms. So suppose we have some sequence where a of n equals 1 over n. Then if we add up all of the terms, the notation that we use here is equals 1 to infinity of a of n. Really, this is like a1 plus a2 plus a3, and so on. And I mean, looking at what these numbers are, this is 1 over 1 plus 1 over 2 plus 1 over 3, 1 over 4, so on. So the way you want to think about this is basically as an infinite sum. So when we're talking about an infinite sum, there are a few things that are not so natural that come up. Some issues that when you're talking about regular addition, we don't have, but now that we're adding up an infinite number of numbers, we do have. So one of the things that we do to talk about the sum of a series is we introduce this sequence of partial sums. So we start out with a sequence a of n. And from this, we can define a new sequence. This is S of n, where this S of n is equal to a1 plus a2 up to a of n. So S of n is the sum of the first n terms. Note that this is very different from the original sequence a of n, because instead of just the terms, now it's the sum of all of the terms up to that number n. And so when we're talking about what does the series actually sum to, we can discuss this in terms of the limit of the sequence of partial sums. Remember, in the previous section we talked about the limit of a sequence. Well, now our S of n is a sequence that is defined in terms of these sums. And so if we look at the limit as n goes to infinity of S of n, this is the same thing as the sum of the infinite series. Now, one issue that came up when talking about the limit of a sequence is that sometimes this limit did not exist. And so just like for sequences, we could define the idea of a convergent sequence and a divergent sequence, we can do the same for series. So a convergent series is a series in which the sequence of partial sums of that series converges. In other words, that limit exists and is equal to a number. And a series is divergent if the limit of the sequence of partial sums does not exist. And where this includes the idea if the limit of the sequence of partial sums is infinite. Since we are dealing with an infinite sum, this is a very common occurrence for a series that there are a lot of series where that may actually add up to infinity.